Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we have a service call for an LG multi V4 system that has a CH2 error code. Thank you to everyone tuning to Jumperman Tech. We are working on an LG multi-V system. It's an inverter system. It's a heat recovery heat pump system, so you can do heating and cooling all at the same time. We have one condensing unit on the roof, and it typically handles anywhere from 7 to 9 air handlers. This is one of them. We have a CH2 error code. There's no access here, so they cut the ceiling up for us because they're going to be installing a larger access panel to fit this space, and we need to see what's going on. I see some kind of wire disconnected there. That actually might be the thermostat. I don't know if that's an old one or what, but that looks strange, and the electrical cover is missing. Let's see what that code stands for. This is the LG HVAC service-business app. A lot of people ask, what app am I using? So we're gonna search up the O2. No error code found, so it's got to be 2. It says error title: inlet pipe temperature sensor of indoor unit. Inlet cause of error: inlet pipe temperature sensor of indoor unit is open or short. I mean, it's pretty straightforward in that sense. Okay, so CH2 is a little hard to see. I can't screenshot here, but it says indoor unit pipe inlet temperature sensor error. Error point: indoor sensor is open or short. Either there's the wrong connection or the sensor is bad. So you want to make sure that it's properly connected. If it is, and I think it's probably bad, yeah, this is kind of a common problem. And we do have the sensors in the building. There are 3 thermistors, 3 sensors for this unit. It's the inlet pipe, the outlet pipe, and air temperatures. So we got 3 sensors in there. At this point, it might be smart to just change all 3 at the same time while we have everything open, because these units go back to 2012 and we're about to be in 2025. Of course, I got my coffee to start the day, and these are the 3 thermistors. That model number is, part number is taken off, but these are our 3 thermistors: pipe in, pipe out, and air. So let's see, as far as this one says 5 kilo ohm thermistor, this one says 10 kilo ohm thermistor. I'm not sure which one this is. Maybe it's also 5K, but anyways, let's go ahead and get started. All right, we just turned the power off. What we're gonna do is drop down these 2 covers to hopefully get inside there. So this panel here, you'll have access to the fans. I'll take out the filter first as well, because when you take off that cover, it's gonna drop.
That's true.
All right, so let's take out the filter, if it's even in there. So the engineer cleaning a filter. Yeah. It is? Yes. All right, let's remove the filter. And we're gonna remove that cover. And we're actually gonna drop this one down. And to really get in there, we're gonna take out the condensate pan and possibly make some space over there. You can pass that in front to me.
Thank you.
Okay. A drop cloth here. That filter could use a little bit of a cleaning. Anyways, let's take all that off and get some access. Got that cover off so we can see things. Also, trying to like slightly bring this down. You gotta take out the condensate pan in there. That is now stuck, so let's hopefully get that out. I had to pull this down a bit, so now this pan can come out. It's a foam condensate pan, styrofoam. Thanks, LG. Look at that, you see these 2 holes? That's because they put the screws in the wrong place. You're not supposed to put screws there. They made a hole in the condensate pan, but those screws are short. They should be okay. We'll check the other side. Basically, we're just gonna pull this thing down. Can't take screenshots here, but there is a resistance temperature chart. So here's for the pipe temperature thermistor, and this is for the air temperature thermistor. So The two pipe temperature thermistors, which I believe are these, are both 5 kilo ohm. And then if you have a different resistance reading for the air temperature sensor, so the resistance will change based on temperature, and the voltage will change based on temperature. Let me see if I can take a picture with another phone. Also, it says you could check the resistance value. Let's see. For the air temperature sensor, resistance value is more than 200 kilo ohms or 4.7 volts, or less than 800 ohms or 0.3 volts, error occurs. Then for the pipe temperature sensor, if it's more than 100 kilo ohms or 4.7 volts, or less than 300 ohms or 0.2 volts, error occurs. So you could check that, but we got all three. We're gonna replace it. I'm sure that thing is bad. I have done this before, and it is a bit tight to get in there. The condensate pan is now out. I don't know about you guys, but I think this could use a little bit of a cleaning. If you guys see that, you know what that is. Oof. Anyways, now we can see our coil. Inside here are the thermistors. One of them, actually. This one right here. Let me get a light. This is our air temperature thermistor right there, the easiest ones to change. And the other ones are like hidden in there. I can see right there, that's one of them with a blue wire. And I see a little bit of red somewhere back there. That's the other one. So we're gonna try to get it through here, get my hand in there. Also, we can try to take out this little side cover. We gotta see what we can take off. But yeah, this unit also could use that cleaning, man. This thing is ridiculous. I have a digital thermometer reading the room temperature, but it's a 59 degrees in this room. It's pretty cold. In this chart, it's in Celsius, so I use Fahrenheit. We're here in America. So it says 15 degrees Celsius. That's going to correspond with 59 degrees Fahrenheit. And it says our resistance should be around 15 kilo ohms. All right, so the way you would check this is you would pull this off the board. It's like this little tab. You press it and pull it off. So there's actually two wires in this thermistor. This is the air temperature thermistor. I'm going to put my leads on the semi-meter to ohms. We're going to read resistance, and I'm going to put my leads on the two little metal pieces here. And we have 14.28 kilo ohms. Okay? Then, if you had it connected to the board, you would be able to stick your leads. You need these little micro leads and go through here to these two little terminals on this connector, and then you could check volts DC for that voltage reading, and you want to make sure you're within that range. So it says in this chart for the air temperature sensor at 15 Celsius, we should be about 15 kilo ohms. So we're within range there. And it's really the pipe inlet thermistor. We're going to check these two, and we could actually compare them to the one that's in there, so then we could know for sure like if it's really a problem. But let's check the next one. I want to see if I can get a picture of the phone here, because this app doesn't allow you to screenshot. I would love to share that information with you guys. But this air temperature thermistor checks out. Okay, so I'm checking this one. Not sure which one is which, but it's the red connector. We'll find out. We have 7 kilo ohms there. Okay. The next one with the white clip, black wire. We have, hold on, let's get a good connection there. We also have 7 kilo ohms. According to this chart on here for the pipe temperature sensor, for 15 degrees Celsius, we should be about 7.9 kilo ohms. So we're pretty much there. Okay. And what does it say? So for as far as this one, if it's more than 100 kilo ohms, it's done. Or less than 300 ohms, it's done. For the air temperature thermistor, we had what, 14.3 kilo ohms. So it says if the value is more than 200 kilo ohms, it's done, or 800 ohms. So we're all in range for these. We're safe to put them in. I would love to see what those other ones read. Let's get started. There is a sequence of operations for this I would like to share with you guys. It says, is the sensor connected to the PCB? If it says no, connected to the PCB, sure. Is the sensor detector installed in the original position? Make sure it's connected to the right spot. If it's not, connected to the PCB. Is the sensor connector pin missing or is the sensor damaged? No, change the sensor. If it is, it says, is the resistance value normal? If we're out of range, change the sensor. If the sensor is in range, it says change the PCB. So keep that in mind. So you definitely want to do your checks here, because if you connect this, if you just change the sensor, doesn't mean it's going to be the problem. It could actually be a bad board. So that's the beauty of this app. It gives you all this information without having to call tech support. And it's like, when you deal with these units, it's like 8 out of 10 times you got to call tech support. So use that app, use it efficiently, and let's be a little thorough with our investigation. Found a cover in the ceiling. Man, this thing is dusty, but anyways, let me open this up. So I can show you the diagram. Where are we? Right here. CN room, that's the room temperature sensor. It says room thermistor. CN pipe / in is the pipe in thermistor. CN pipe out is the pipe out thermistor. So through here, we'll be able to know which one is which, and they each have a different color. Alright, it's honestly a bit hard to get in here. This panel's freaking gross. So we got something. What is this? It's a good thermostat connection. Is it even connected? Anyways, guys, we have a couple of thermistors up top here. This, I think, is the thermostat. We have a red connector here. This guy right here. Red connector, blue wires. And we have this one, black connector with blue wires with a white. And then, anyone else is there? We have this one right here with the yellow connector, which, so I think this is the yellow is the room. This one, the the white connector. Let me see, room. It's actually backwards, this diagram, as far as how it's mounted. So on the right, yeah, is the room. So the yellow one is the room thermistor, the white one is the pipe in, and the other one is red, is the pipe out, and to the left of that is CN-REMO, which is our wired remote controller. Okay, so it is connected. So which one is it? The middle one. This one. I'm just gonna press down on the clip and pull it out, and we could check resistance. Okay, let's check between the two leads with the power off, right? And disconnected. Look at that, 385 ohms. 385 ohms. Let's look back at our manual. 385 ohms, I'm pretty sure that's bad. So the pipe in 15 ohms, right? We should get about 7 kilo ohms. Then says the pipe temperature sensor. If the value is more than 100 kiloohms, it's bad. Or less than 300 ohms. But it's a completely different reading than the new one and doesn't follow that chart. Let me see, pipe in temperature thermistor. $300 ohms, huh? Got a little calculator here. So 385 ohms is 0.3 kiloohms. .3 kiloohms. It's basically telling me it's 100 degrees in here when it's 59 degrees. It's gotta be bad. You know what else I'm curious of? What does the other pipe temperature sensor say? Is that in range? Oh man. Hopefully you guys can even see what I'm doing. Well, basically I'm just putting my leads on the two terminals. Oh, look at that. If you guys can see, 7.28 kiloohms, and we are in range with the new ones at around 7 kiloohms. So that one is pretty off. It's only 0.3 kiloohms. So yep, we got a bad sensor. All right, it's not the board. This unit's old, and these thermistors are inexpensive while we're doing all this work. You know, it's like a domino effect with these thermistors. So what we're gonna do is change all of them. So this one first, let's get that out. Let's feed this through. This is definitely gonna be the easiest one to do. It's gonna be your pipe in thermistor. I know you guys can't really see, but I'll show you guys in the end. That's how easy it is to get to this one. And it's out. Here's the new one, all original manufacturing parts. And yes, it's a yellow connector. So we're just gonna fit that in place on the board and mount the one here. Okay, so the way they had this was one in here, and then this basically squeezed in here. Oh, go around, tuck it in. Let me go a little more, maybe something like that. Actually like a little cover. Let's get this in right. Probably gonna have to tighten that screw after. And we gotta get this really in there. Right there. Now it's starting to go through. Something like that. Have to tighten that screw. I'm gonna push this through the hole here. Connect it to the board. Okay, let's see, hold this straight. Right there, okay. Now that can hold in there, and we're just gonna connect this fitting, this little connector, where it's supposed to go, where we took out the other one. I'm gonna hold the camera with one hand so you guys can hopefully see, but it's hard to see, but there's a yellow connector there. So what are you gonna do? You're gonna put the yellow with the yellow, right? Only makes sense. Make sure this is in the right position, and all you do is, oh man, I gotta get my other hand in there. I got like everything on me, and I got my back against the wall. Ah, this is not fun. Come on. This is supposed to be easy. It's hard. Oh, I can't get in there. Okay, come on. Barely see anything too. My head is against that thing. There's no space here, man. Is it gonna go back? Barely see anything. Yeah, it's supposed to be easy, but it's not. Come on, man. It's Friday, why are you doing this to me? Barely see where I'm even going. Right there. And it's in. If you can even see it right there. So that's in, that's done. We gotta get to these others now. These are tough. Okay, so what I do is, there's a little cover here you can open up so you get your hands in here, and you can squeeze a bit through here. And sometimes I even have to pull this out just to get my hand in there. All right, there's some few Phillips screws here. Let's get that off and see if we can get in there. It is for sure tight. You're gonna need your angle bit or like some kind of small stubby screwdriver. Very difficult placing for everything. Let's get this plate off. Oops. Let's see how much access I really have. Got Christian cleaning up the filter, the pan, and the other cover. I can't stand to put things back like that. Okay, this is free. We have a little bit more space in there. This part is a little gross. But they got this piece here, which honestly, I'll just take out for now, just to get a little bit more space in here because I see the thermistor, it's in here. I'll give you guys a close-up. All right, so in here, we have one thermistor right there, the black wire, and then we have the red one right there. See that? A little bit hard to get to. Personally, this is my best way of getting it out. There is another little cover you could take off here. You could pull out that pump. But seriously, there's like barely any space there, and it's a very hard angle. I find this to be the best way. This is why we do those cleanings, guys. Look at that. That thing is like a rug, have barely any airflow. Let's see if I can get inside here so you guys can peek at that coil. Look at that coil. Come on, man. Whose man's is this? Alright, listen, we're gonna do what we were asked. But we're definitely gonna have to come back to clean this thing. We do finally have a contract to clean the entire building. But I don't know what's the hold up on that. But anyways, let's just get this going. Alright, so listen, it's gonna be very difficult for me to show this in such a tight space. I mean, it's hard just to do it. It's gonna be even harder to like get this on camera, but anyways. I got a pair of needle nose and a little electronics thermostat screwdriver. Let me tell you guys what I'm gonna do here so you guys can really see it. Let's see, who can we see? So if you look here, you see this little metal piece sticking out right there? You're gonna bend that back and pull out the thermistor. That's what holds it in place. Can you see it on this one a little better maybe? So right here, there's this, oh come on, can I even get in there? No, I can't. Come on. There's this little metal tab. It's a little hard to get in there. There's a little metal tab, if you can see it. You're gonna pull that back and then pull out the thermistor because that's what holds it in place. So that's what I'm gonna attempt to do right now. Barely see anything, but I'm gonna get in there. So it's kind of, yeah, there we go. Pull that tab a little back. And now I can pull out the thermistor. There we go. I pulled it out. Basically that tab is in there and it holds it in place, so it's tight against the copper that it sits in. So now that's like that. The black wire. Black wire. Oh, it's this guy right here, right? Yes. Hey, Chris, let me get a pair of snips.
Got it.
There's a tie wrap here. Okay, so that one is now in. It's holding tight. Just gotta plug this one into the board. White connector here, connect to the white part in the board. And we're gonna try to get to that one. I want red one. I want to. Seems a little tough. Who made this, man? Come on, what is wrong with these people? I don't know if you guys can even see. I'm gonna pull that little tab. Looks like the thermostat screwdriver does the best thing. Sheesh, tab broke off. That's great. Anyways, got that out. Let's pull out this thermistor. Come on. I'm gonna do this now. I'm gonna pull it with the needle nose. Hopefully that's a little better. What a mess. And look how to pull it out goes right against the pipe. I'll take a picture. Thanks, LG. Come on. Why would they do that? Unless it's supposed to go in the other way, but there's not even space to do that. What the heck, man? Why would they do that? I don't want to bend that pipe. I have to bend it a little bit to even try to get that out. Wire already broke off. I'm pulling it with the sensor. Either way, I think it's bad, right? Oh, I just popped it out. It came out though. Let's get the new one in without destroying it, right? So that one is gonna be the red cable. Right here. Pull that out. Okay, the sensor is freaking gone, man. Basically, the same hole that it came from, just gonna push it through. Let's hope we make it through. Is it going through? Oh yeah, it's in there. Can we get to it? Basically, we're gonna push it through and pull that thing out. There's no space with this here. And push it through. Hopefully, it clears up. Oh, there we go. There we go. Let me get it there. There we go. Gonna attach it and plug it in.
2,000 years later.
All right, guys, it was a mission and a half to try to get into that spot. Can you even see it? Where is it? Yeah, right there. Those two. Super tight. Really was difficult. Got everything plugged in, matching the colors. Good there. Let's put this pan back up and close this thing. Should be good to go here. Let's close up this cover. Put this stuff back. I'll start the first one by hand just to hold it in place a bit. Then put that little insulation thing back on. Maybe they don't want it to rub out or something, or try to insulate it, whatever. All right, we got this cover back on. Put this little insulation piece back on. Clean the pan. This part is just rusted from that. That don't clean off. So let's push this in.
Sad, I'm not judging you for talking to yourself.
Talking to the audience, not myself. Tuck this in. There we go. Now we're in. Put this cover back. Okay. We're gonna put the screws in here. Right here. These two, you don't put any screws in here. can see the white insulation from the foam. You just put screws here, 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 and around, because you start making holes out here, and we don't want that. So whoever worked on this before, shame on you, my friend. Alright guys, all the covers are on, filter. Now I even put on the electrical cover. I just turned the power on. Let's see what happens. Alright, got the system in heating, set to 86 degrees. No air codes. And let me turn this on. We have 105 degrees. We're gonna wrap it up from here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. I'll catch you all next time.